Hello everyone. Am I audible?
Yes, Utkarsh.
Okay, before starting with the event, I would like to introduce myself. Myself Utkarsha with Punyai. We will be hosting the session today. Also, I would like to tell you some rules. Please keep your mic off during someone is presenting and please avoid the disturbance in the background. I request you all.
Good morning, Lata madam.
Good morning. Good morning.
Good morning, Dasre sir.
Good morning, everyone. Good morning, Saji.
Good morning, sir. Utkarsha, you may start.
So can we start the event?
Yes, ma'am.
Yes.
Good morning. A very warm welcome to each and everyone present here. I welcome guest of honor, Deputy CEO of Pillai HSL Educational Campus, Dr. Lata Menon, Principal of Pillai HSC College of Engineering and Technology, Mr. J.W. Bakal, and our judges for the contest, Dr. Narendra Kumar Dasri from RAIT and Dr. Sachin Wani from PCE. We are grateful to you as you have graced this event by your presence. I likewise welcome all the camps of today's competition and audience for joining us. We are proud to be able to host this magnificent event with all of you. I would like to hand over to the guest Lata ma'am to express couple of words with our participants and students.
Hello. Good morning, everyone. On the occasion of Pi Day tomorrow, I know every year PHCT organizes, comes up with some innovative idea, and very happy to see the response they get for the ideas. Definitely, these are the activities that stimulate student minds into mathematical thinking, which is very important and very useful for lifetime, I would say. I wish all the presenting teams all the best. I wish the organizing team all the best, and I congratulate PHCT and Dr. Avinash Kamble and his team for coming up with yet another interesting session. All the best once again. Thank you very much, everyone.
Thank you, Lata ma'am. Moving towards our next guest, Principal Sir, to speak few words and stimulate our students.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning,
Good
sir.
morning, sir.
Swaminathan, Deputy CEO of Pillai HUC Rasayani campus. Judges, both the judges, Dr. Dasre sir, Wani sir, and the important person who could make it to happen, exploring the idea of the other side, the pi 22 by 7, 3.14, and pioneering this idea. Wherein this idea, when I was chairman of IT and the sir was been knowing, that time I tried like the syllabi of computer and IT should be different than the other applied mathematics. Wherein I thought like there is going to be huge demand for big data analytics, and let us have the base of semester 3 and semester 4 as a statistics so that they can use. Now the data analytics part becomes little bit hidden side of it, but the front side is now AI, artificial intelligence, machine learning, deep learning, wherein you will be getting definitely the components which are useful to utilize this, because this mathematics you will be using as a tool. And the fear factor in the 12th standard or from the 8th standard or from the KG onwards, oh, mathematics, very dangerous, very dangerous. But you cannot solve the complex problem without the help of mathematics. So mathematics is a must. Those who are from the IITs or those who were sometimes like attended some STTPs also, the person who starts teaching something, he will be starting with directly, Fourier series, Laplace transform, and it goes above our head. It is not even tangential, not even normal. It goes above only. But the idea, the club for exploring this pioneership of other side of the, you are generally seeing the front side of it. So other side of the mathematics, which is going to be very, very useful to solve the complex system with complex variable, and having so many tools available now. So this is going to be definitely benefited to the students who are participating, and some idea will be definitely pitched, which we can take further to take as a project, maybe for TA onwards. That will help in toto to PSCET and the other teams from which they are from different colleges. These colleges also will get benefited. Once again, I congratulate Dr. Avinash Kambre for having this idea and pitching this idea. In between, he used to come and sir, I feel like I was busy with other activities that we had yesterday. Like. Degree distribution ceremony, and the total count was 1700, two batches. So it was packed day for me for last week. So whatever help Dr. Avinash will be required, I am there, and with the help of Deputy CEO, we will definitely resolve, and we will see that many more events to happen like this. Thank you very much. All the best.
Thank you, sir.
Thank you, Principal Sir. Much thanks to all the guests for the significant word. Now I would like to introduce our judges. Narendra Kumar Dasre Sir is an Associate Professor in Applied Mathematics at Ramrao Adik Institute of Technology, Nerul, Navi Mumbai, which is now under the ambit of Dr. D.Y. Patil deemed to be university. I would request Sir to express couple of words and inspire our undergraduates and motivate them for the future.
Okay. Thank you. I first of all congratulate all the participants for participating in such a good event. I thank the management, the CEO Madam, Bakal Sir, and Avinash Kamble Sir for to be judge of such a wonderful event. Now we say that pi. Okay, so pi has always inspired mathematicians. Pi has always been a mysterious number, and pi has been the challenge up to it. So pi has played and is playing an important role in even technology. So one thing I want to tell about pi, why this number is so mysterious, why this number is so challenging, or why this number is so important. Whenever we go for measuring the speed of any machine, okay, so speed, now we say we have a dual core processor, we have a core processor, we have i5, i7, 10 generation, 11 generation and all. So how the speed is decided? Okay. So pi can be calculated accurate up to millions of digits, but still there is always a chance for another million. And this pi is used as a measure of the speed of calculation of any processor when it is tested. So that's why the pi is very important number or very fascinating number, or it always challenges. And as we go into the value of pi, millions of digits we can cross, but still it claims to be a challenge again. So I hope all of the participants will explore, as the theme for this presentation is AI and ML. So this pi is very important. Let us try to explore the ideas by young minds. Okay, so I hope all the best to all the teams. Thank you. Let us explore the AI and ML through this Pi Day.
Thank you, sir, for your motivation. Now I request Sachin Vani, sir, who is Associate Professor in Department of Applied Mathematics at Pillai College of Engineering, New Panvel, Navi Mumbai, to speak few words with our undergraduates.
Thank you. Good morning, all. I would like to thank Deputy CEO Lata Menon ma'am, Principal Sir Dr. Jagdish Bakal sir, and the Program Coordinator Dr. Avinash Kamble, and Shivam and Sahana from Pillai HOC College for giving me an opportunity to be a part of this wonderful program as a judge for this competition. I would like to congratulate Dr. Avinash Kamble sir to start such an Inspire Mathematical Club and to organize such a wonderful presentation competition on exploring the other sides of mathematics as the Inspire Mathematics Club activity. The topics which included for presentation competition, that is mathematics in artificial intelligence, data science, and machine learning, all are the most demanding and trending fields in today's world. Artificial intelligence is used almost everywhere and being rapidly commercialized, with new applications being created not just for manufacturing but also for banking, energy, IT, healthcare, economics, everywhere. This will change how we all do the business in few years. It will improve business results by infusing machine intelligence into day-to-day decisions, using a combination of automation, prediction, and optimization. All the big companies like Google, Microsoft, Ola, all these are using these techniques to improve their business. In few years, artificial intelligence virtual assistants will be as common as a smartphone. Now, data science is the process of using the algorithms, methods, and systems to extract knowledge and insights from structured and unstructured data. It applies advanced analytics and machine learning to help users to predict and optimize the business outcomes. Artificial intelligence and data science focuses on collecting, categorizing, strategizing, analyzing, and interpretation of data. All these can be highly technical and somewhat confusing to those of us who do not have mathematical backgrounds. To make better decisions with predictions and optimization, you must have a better understanding of mathematics. When you Google for the math requirements for data science, the some topics that you will find are calculus, linear algebra, and statistics, discrete mathematics. If you don't have a strong background in probability and statistics like regression analysis and linear algebra, that is in matrices, you will not be able to become a data scientist. Or if you want to work in artificial intelligence or machine learning, you must have all the basic mathematical concept of calculus and algebra. So without wasting time now, I will congratulate all the participants who have participated and selected for the final presentation, and all the best for presentation. Perform well. That's all from my side. Over to you, sir.
Thank you, sir, for your valuable word. It must have motivated the students. Moving further, Inspire is a mathematics club initiated by the students and faculty of Applied Science and Humanities of Pillai HOC College of Engineering and Technology, Rasayani. On 22nd December 2020, Inspire Mathematics Club was launched by the members of the club, guided by Dr. Avinash Kamble on the occasion of National Mathematics Day. Inspire has been conducting interesting events for the students till date and will be continuing further. Here's a brief video of Inspire Mathematics Club. So today we are here to celebrate International Day of Mathematics, which is celebrated every year on 14th March. An Inspire Mathematics Club has organized a presentation competition for undergraduate students. Our passion helps us all to unite, and the energy we create is what allows us to achieve our individual as well as group goals. Before we get started, I would like to express my best wishes to all of you who are making this event come together to become a success. Before moving ahead with the event, let me read out the rules and regulations given to the participant, and they are requested to follow the rules and regulations. Each group will be given 7 minutes for presentation. Only one participant from each group will present. Each group will be questioned at the end of the presentation by our respective judges. Presentation should be live presentation and recorded ones are not allowed as informed earlier. That's all for the rules and regulations. Each group is requested to follow the rules. We are having total 10 groups for the competition. Each group will be called out one by one. So we will begin with our first group. Group number 1 will be presenting on the topic Mathematics in Recommendation System using Machine Learning. Please share the screen and start with the presentation.
Good morning, respected judges and my fellow participants. Today, my topic of our group is mathematics in recommendation system and using machine learning. We are students from Somaya Vidya Vihar, and our mentor is Professor Vinayak Apode. Now, what is recommendation systems? Recommendation systems provide users decision prediction and assistance using machine learning, artificial intelligence, particularly computational intelligence and machine learning methods and algorithms have application in developments of recommendation systems. There are two types of recommendation systems in general. First one is non-personalized, and second, popularity recommendations, which which simply recommend which is popular among us all users, and customized recommendation system which makes recommendation based on information about the content or the users viewing behavior. Content based collaborative filtering and hybrid personalization systems are the three basic types of personalization systems. They are discussed in further slides. Now, first of all, we might have thought many a times, how are recommendations given to us? How do the system predicts recommendations? Let me tell you, we employ a matrix, which is a set of numbers organized in rows and columns, with rows representing users and columns representing the items. For example, movies or products that you want, like on Amazon, you search for a product, etc. Each cell in the matrix carries a number that indicates how much each person likes each film. For example, we may use a 0 to 4 scale, with 0 representing I hate it and leveling up to 4 representing that the user loves the product. There will be some collection of preferred data for users at any one time, but it will be incomplete because not everyone has seen every movie. Based on the other values in the matrix, the recommendation algorithm must predict these missing values. The problem can be approached in two ways. First one, content filtering. Content filtering involves using the knowledge we already have about the people and things as connective tissues for making suggestions. It's the equivalent of asking a user, say some user named Sana, what kind of movie she enjoys, and if she likes another specific movie or not. It starts by assigning each person a movie, each person and movie a set of characters or features such as horror, science fiction, or comedy, or romance. If Sana likes comedy but dislikes horror, we can give her 3 for comedy and 0 for horror. If we want to suggest Conjuring to her, it will be a bad idea since she does not like horror movies, and Conjuring is mostly based on horror movies, on horror. Now we must multiply. You can see in the slide the user table and the movie table. We must multiply these two to get a resulting matrix known as preference matrix. To get the after getting the preference matrix, we must reduce it to the scale of 0 to 4 to get the idea of ratings of movie for a particular user. This method of content filtering has some drawbacks to it because there are more relevant features to a movie than just comedy, romance, and horror. The way to improve this method is by increasing the number of features in this matrix. Now, next method we go is about collaborative filtering. The theory behind collaborative filtering is that a user will likely enjoy things that others with similar watching pattern enjoy as well. To generate features, we use the user preference data that we do have. We can say that two consumers have similar preference if they grade the same movie the same rating. To figure out what to recommend to the user, we look at what other users with similar taste are watching. For instance, suppose we had a matrix containing missing data such as 4 users and 5 movies. The matrix displays how much each user has voted for each film. However, it does not imply that all users have rated all the films. Like you can see here, user 1 has not rated movie number 3 and movie number 5, but we can calculate this with the help of other users like user number 3 who has rated the movie 3 as 0.75 and 5 as 2. For this we have machine learning algorithms. We first reduce and estimate factorization into two metrics. The machine learning algorithm's job is to guess the value of those metrics that will most closely match the existing data in the preference matrix. The easiest method is to guess the number over and over until we find a perfect set of numbers that accurately predicts the data. After we have completed this estimation, we may multiply this matrix again to fill in all the missing values. Because we don't know what the characteristics are in this scenario, we refer to them as latent features. They are similar to the average or weighted sum of the data patterns. It's worth noting that this type of prediction is usually a type of compression because a large matrix of preference data can be represented by two tiny matrices of feature data. We can discard the original data with missing values once we have discovered our feature data. To reproduce preference data, we simply multiply the feature matrix. This approach is known as matrix factorization. Now, another approach is by using cosine similarity formula. The formula goes like SC A comma B equals cos theta, where cos theta is equal to summation of AI into BI upon under root AI square into BI square. Now let me explain to you how this formula works. By substituting values in equation, we want to find whether user 1 and 2 and 1 and 4 have similar interest or not. We first substitute the values in the equation for user 1 and 2. We get the similarity value as 0.3938, 0.9383. We get the similarity values for user 1 and 4 as 0.8994. Now we estimate rating for user 1 and for movie number 5. For that, we use uh, uh, F1 and 5. 1 and 5, which is calculated as similarity of user 1 and 2 into rating user 2 gave the movie number 5. The similarity in value 1 and 4 into rating user 4 gave to movie 5 divided by the similarities in value. Thus, according to the given data, the recommender would predict that user 1 would rate movie 5 around 3.5. This means that movie 5 might be the user's preference and thus will recommend it to user 1. Using the formula, we can find all the missing values in our preference data. But there are some drawbacks to this. Sparsity is one of the problems. Users don't always rate the movies after watching the movie. This results in having matrix with lot of movies and lot of users, but very few values for rating. This makes it harder to find users with similar preference and thus makes the task difficult. Scalability. When there are ton of movies and users, the system might slow down considerably as there are a lot of calculations in this. Cold sort is one of the biggest problems since recommending new users might be a big task. Content based and collaborative filtering are two prevalent ways for filtering recommendations, but they aren't enough data to learn the relationship between the user and the items. These solutions run into problems. In such instances, the hybrid recommendation system, a third type of technique, is used to develop recommendation systems. The disadvantage of both content-based and collaborative filtering methods are overcome with this approach. Thank you for giving us such a wonderful opportunity. We are open for any questions from judges.
Thank you. Now I request our judges to ask few questions.
Hello. Hello. Can you
Yes,
audible?
sir.
Okay. So you are talking about some preference matrix, right?
Yes, sir.
Yeah, we are finding this with the help of multiplication of two matrices, correct? But if
Yes.
there are two matrices where multiplication is not possible, then how you implement this system? Where multiplication is not possible, because we know that multiplication is not always there.
Yes, sir. We can just reduce the matrix to a place where multiplication is possible. Like we need to have m into n, comma n into p number of. Uh, that is the basics of matrix multiplication. We
But
can just
how?
I would
Yes.
just a second. I would like to add that matrix multiplication is just one of the methods that we have put in our presentation. Like there are much more preferable ways to do like preferable methods for recommendation systems. Like we mentioned, the using the cosine formula to find the missing values in the given data.
So, but how you decide which row to delete and which column to delete, or randomly we can delete to get the multiplication of matrix?
No, we won't be deleting. Matrix multiplication will be preferred when we have that m into n by n into p type of matrices. In case we don't have that type of matrix, we can do this by other methods like cosine formula and other methods like that.
Okay. Can you elaborate more on cold sort? What is that? Cold sort?
Sir, it is just
Uh,
that one of the drawback of using collaborative filtering for new users, we don't have any data regarding them. So it is difficult to recommend them on the basis because we don't have data, right? That is basically also.
Okay. One more. You just give an example with that movies, right? Movies, and you created that matrix. Can you give some other examples where this system is used? In day-to-day life, we are using that system, but where actually? Do you know?
So it is used in many recommendation systems. Like even if we are using an app that gives us news, it will be recording what kind of news that we usually click on or usually prefer to read. So basically, all types of um, recommend in um, even in shows or books or music recommendations like Spotify link. Everywhere we use recommendation systems.
Okay, okay. The best example, if you see now, if you search something in Google, right? We are always searching in Google any video or YouTube, then automatically all the related videos are coming. That is also one type of recommendation system they are using. Uh, okay, that's all from my side. Over to Dasre sir.
Can you please go to the slide of your presentation where you have defined similarity? You have defined something similarity of user one and user two or something like that. So please, can you go
Yes,
to
sir.
that slide? Yeah.
Yes, sir. Just a second.
Yeah. You have defined this similarity. What is the formula for similarity?
Sir, we have, sir, cosine similarity. It is basically cosine similarity.
Okay, cosine similarity.
Yes, sir.
What we do exactly here?
Sir, summation of all values of a comma b. Sir, we have even shown the calculations here. Sir, for this is
That's
the
okay.
value of a, value of
Mhm.
b, summation of all values of ai into bi
Mhm.
upon under root of squares of ai and bi.
Squares of A and BI.
Yes.
So basically, A and B are like considered like two vectors, and then we are performing this function over that.
So here, as you have considered that some of the users have not given rating to some movies, or suppose some of the users have not been to that movies. Okay. Yes, here you have given question marks. Okay. So what you consider here? They are likely to recommend or they are not likely to recommend?
Sir, what we have kept in the presentation, as you can see, in case of user one, the user one has not rated movie number 5. So so the example that we have given is we are finding whether user one will like it or not. So in that we are like by the formula we are getting the value prediction as 3.51, and our scale is from 0 to 4. So 3.51 is like very good on the scale. So we can like from the value we can tell that they'll probably like the movie.
Correct. Okay. Now again, I want to go to the formula of similarity that you have defined.
Yes.
Ah, yes. Okay. So if we see the formula, okay, does it have anything to do with the angle between two vectors?
Sir, we are calculating cos theta, right? So there is a
Formula for to calculate, if I take cos inverse on the other hand side, it is nothing but angle between the two vectors,
sir, it is
right?
basically dot product. If you
Yes.
can see dot product a dot b upon mod of
Hmm.
ab.
Okay. So thank you. Okay, thank you from my side.
Can you call
Thank you, sir.
Thank you, judges. Calling out our next group, group number 2, who will be performing on the topic image enhancement. Kindly share the screen and start with the presentation.
When shall we start? Hello.
So
Excuse
just
me, wait a minute.
yep.
Are you going group number which is mentioned in the sheet or random?
So we are group number 2.
Group number 2. Okay, okay.
Yes. So can we start? Good morning to one and all who is present in this virtual meeting. We are the student of the Universal College of Engineering of Computer Branch. Myself, Himanshu Yadav, with my team members Yamin Venchu and Rutik Borke, are going to give a conceptual explanation on the topic image enhancement. Topics to be covered for the presentation are mean, median mode, QQ plot, left skewed, right skewed, quantile transformation, standard deviation, and percentile. And at the last, using all these mathematical concept, we are going to show a demo of our project. Now, I would like to hand over to Rutik, who will further continue with the presentation.
Thank you, Himanshu. Our next topic is mean. The mean is sum of data divided by total number of data. Now, we take an example. In this given set of data, there are 8 numbers. Then, add that all numbers. So, the mean will be equal to 54 divided by 8. That gives us 6.75. So, the mean of this set is 6.75. Next slide. Our next topic is median. The median is central value of the given data. Now we take an example. In given set of data, the firstly we need arrange the value in ascending order from the least number to the highest number. There are 8 numbers. The numbers in the sets are even. So the add the middle of the 10 and 24. So the median will be equal to 34 divided by 2. That gives us 70. So the median of this set is 70. Next slide. Our next topic is mode. The mode is defined as the value that has a higher frequency in a given set of values. It is a value that appears the most of the time. Now, we take an example. In the given set of data, there are 6 numbers. Hence, the mode of the given set of data is 5 because it appears set in twice. Next slide. Our next topic is positive skew. Next slide. We wanted to look at the graph and the income distribution per annum in particular region. So we have the income in dollars at the bottom of the slide. The ranges is going from $10,000 to $1 lakh. That gives you find. The majority of the people earn somewhere between $20,000 to the $15,000. Very few earn more than $10,000 and very few earn more than $10,000. Hence, the central value around the $15,000. We can see a long tail on the right hand side of the central value. It surely looks like a tail, but there is a important thing, that is the tail is positive side of the central value. Hence, we say that the distribution is positive skew. Next slide. Our next topic is negative skew. We have the data of the marks scored by the student in the easy test. Next slide. The ranges marks from 15 to 18. This is time the distribution looks like this. Next slide. This is the distribution of the marks of the student. Majority of the students score between to 15 to 18, while the central value is 50. Next slide. We see a tail as well as, but this is time it lies on left hand side of the central value because it's kept towards the left hand side of the central value. Hence, we can say that the distribution is negative skew. Next slide. I would like to hand over Himanshu. He will be further continue with your presentation.
Thank you, Rutik. Now I'm going to explain QQ plot. Basically, Q means quantile. It is a percentage of the point below a given value in our data set, often referred to as percentiles. Example, median. Median is a quantile where 50% of the data lies below and above that. A QQ plot is a scatter plot of two sets of quantities against each other. As you can see the second graph, if the two sets comes from a population with the same distribution, the points falls approximately along a 45-degree reference line. And as you can see the first graph, the point at the right corner is far away from the normal. That point is known as outlier. We often use QQ plot because it answers the following thing: if the distribution have a similar shape, if they have common location, and many more. Now let's see how to make a QQ plot. As you can see on the screen, then we have to find a normal distribution of a given set of numbers. So the first step is to sort the numbers from smallest to largest, and second step is to draw a normal distribution curve, and third step is to find the z value from each segment. The formula to find the z value is x minus mean upon standard deviation. Basically, x is the number which is given in the question, and fourth step is to plot the data set values against the z values. By plotting this on, the QQ plot has almost straight line indicating that the data is approximately in a normal form. Next slide. Now I'm going to continue with the standard deviation. Standard deviation measures the spread of the data about the mean value. It measures the absolute variability of the distribution. The higher the dispersion of the greater is the standard deviation and greater will be the magnitude of the deviation of the value from the mean. It is useful in comparing the sets of data which may have same mean but the different range. As you can see on the screen, the formula for the standard deviation, where n is the number of the data points and xi is the each value of the data and x bar is the mean. And at the right corner, you can see the normal distribution curve. If it ranges from -1 to 1, its standard deviation is 68%. If it ranges from -2 to 2, its standard deviation is 95%. And if it ranges from -3 to 3, its standard deviation is 99.7%. Now I would like to hand over to Yami. He will further continue with the presentation.
Thank you, Himanshu. Now I would like to continue with quantile transformation. So for why we need quantile transformation. So basically, as you can see in our left, the data is not normalized properly. Quantiles are nothing but we divides the data in equal parts. So here you can see all sample 1, sample 2 and sample 3, the quantiles are plotted here, but they are not normalized. Now, quantile transformation can also be used to put non-distributed data to a normal distribution. So we're mainly going to use it to convert our data into a normal distribution. So how quantile transformation work? As you can see, the top of this data quantile points, what we will do, we will take the mean of this three and then we will plot a line and then we will plot it this way, and same goes for others. As you can see, our data has been completely normalized, but as you can see, the properties of data point remains the same. As you can see, this uh, lower quantile point is still being the lowest in the whole data point, and same goes for others. Next, we are going to use percentage. Percentile. Sorry, percentile is nothing but it can help us to find. Suppose here this is a data set of seven data points. Suppose we have to find the 100th percentile of the data set is definitely this. Same we can find 25 percentile to 50 percentile to 75 percentiles quantile points also with the help of percentile. Now I would like to say if you want to access the Collab notebook and see a project demonstration, kindly scan the QR codes for better reference. So I would like to give a brief introduction about the project, what is the project is really is. So we are doing image enhancement using all the mathematical concept my teammates has just explained. What we are trying to do is segment the different intensity pixels, and suppose like finding the highest intensity pixel in the highest groups of intensity pixels in an image and trying to normalize it. That way we can segment different intensities and then we can correct them. So I will first show some result and then we will dive into the algorithm. So as you can see, by using this algorithm, the input was this low light image, and we have successfully created this low light image into an enhanced image or more of normalized image, you can say, for human eye. So here you can see many details like the cloud was missing in an image. We can we really get it with this, and the shadows and all. So we will the next is like this overexposed image we have as an input, and the output we have tried to get all the details out of it with the help of this algorithm. So basically what does it do? First it checks how the image is really overexposed or low light, and based on that it tries to we try to do some calculation to get this output. So I will start with the algorithm. Basically we are importing image using OpenCV. Basically all our image what we're going to all the mathematics we're going to use is going to happen with the help of OpenCV. First we read the image, and then basically the default in OpenCV when it reads the image, it has BRGB format. So we just convert it into an RGB format, and then basically what we are going to do is put that image into a Panda data frame so we can do more analysis on it. So we are just taking the RGB green value of a particular pixel, then we are calculating the intensity, and then we have converted into an panda data frame. As you can see, the features of this data frame is pixel number. It is a 0 pixel. The position is 00, and its RGB is 13, 8, 12, and its intensity is 9 point something. So this is our data frame. Now we will start doing our visualization. With the help of this panda function hist, we have plotted this image. Now by looking at this image, you can say, looking at this chart, we can say that it is a left screw chart. So what do you think the image is? So the image, by looking at it because of its left screwedness, you can say the image is low light because the pixels from 0 to 50 50 values are mainly the most, and based on this assumption, we can say the image is low light. So here is a small function which just returns the score, whether the image is low light or an overexposed image using skewness. Then you can see we cannot work on this image because it's left skewness. We have to normalize the data so we can do more mathematics on it. So we will convert the image to a normal distribution. As I've explained what is quantile transformation, we are doing the quantile transformation here, and as you can see the output, first it was less skewed and now it is normally distributed, and with the help of QQ plot also you can see we can see the outliers. These pixels are way high, like 25, 25, 25, and these are like 0, 0, 0, and you can see now it is more over a normal distribution. Now why we first created into a normal distribution, so we can use different like functions of normal distribution, like we can figure out the intensity of pixels by just calculating the standard deviation. Suppose we can say give us all the pixels which are 3 standard deviation away, or 2 standard deviation away, or minus 3 standard deviation away. So here we are going to do the same. We are going to use percentiles to find out different intensities, and also we can also use standard deviations also to find out different intensity of pixels, and you can segment the pixels this way. So we are using here percentile. So we are telling it simply to take pixel 0.98 percentile to 100 percentile. As you can see, there are around 10,000 pixels which have this intensity, and then same we can do with the standard deviation away. We are saying that take all the pixels which are 2.2 standard deviation away, and as you can see there are around 7,000 pixels. And then we are simply, what we are doing is, after getting these pixels are mainly of high intensity, so we are just plotting it an image. We are taking this image and just, if you can see, we have successfully plotted all the high intensity pixels in it. And then we will move for the final overall enhancement we were talking about. We have created these two functions which one handles the overexposed image and another handle the low light image. And based on the above function we have created, which gives us an output, we use one of these functions. So as you can see, this is the result after taking out. You can see the sky was totally dark. We have tried to gain some light on it, and you can even see this part was so light. We can find out different details, and it is overall an enhanced image. So I would like to conclude the presentation by saying that while using all these methods of statics, we have converted an image to an enhanced image, like mean, standard deviation, QQ plot for analyzation, and quantile transformation for converting our some kind of misnormalized data into a normalized data. And by using Python, pandas, and sklearn, some functions of sklearn and skp, we have make this algorithm. This algorithm can be used in various applications. Suppose a web server is taking as an input as an image, we can put it there. If we can just alert the user that your image is super low light or overexposed, or we can do our own corrections on it if we wish to. So I would like us to say thank you.
Thank you for the presentation. Now I request our judges to ask few questions.
Okay, see, you are using here statistics, right? All the statistic concept you have just explained, mean, mode, median, whatever you explained.
Yes, sir.
Yeah, this is whatever concept you are using in statistics here, right? This is all for ungrouped data, right?
Yeah.
Can we do this is for group data?
Group data, sir.
Group data. You have done all these calculation, the mean, mode, median, these all are actually ungrouped data. So can you do this for group data also, such calculations?
Yeah, it was actually ungrouped by while we did that quantile transformation. We somehow grouped it into a normal distribution, and based on that, we are doing it.
Okay, one more. How you decide the parameters while enhancing the image?
Yeah, so I can present again.
No, you can just explain.
Okay, so what we are actually doing is, oh my god, sorry. So what we are doing is, like, first of all, as we can now we have once our data is normally distributed, now we know that after 3 standard deviation away, obviously the pixel is going to be an high intensity pixel. So what we are doing is we are looping over all these standard deviations from -1, from -3 to +3, and somehow we are trying to, like, just suppose it's suppose it's 25, 25, 25, 3 standard deviation away, the red, green, blue pixels values are. So what we are doing is reducing 50 out of it. So it's becoming then 215, 215, 215, somewhat like this.
So just trial and error method or you have some specific one?
Now, because it is 3 standard deviation away, we know it's high, so we are decreasing it.
So it's trial and error method, right?
Yeah.
Okay, one more. You are talking about negative skew, positive skew. What is actually the effect of this on the image?
Yeah,
Negative
so
skew,
if
positive.
the image is negatively screwed, okay, so we can just say because it is negatively screwed, all the maximum pixels are actually in the low side. Okay, so we can just by with the help of right screwed and left screwed, we can detect whether the image is a low light or overexposed image.
Okay. Last, have you studied any other method for image enhancement other than statistics?
Yeah, I've seen histographic enhancement. There is contrast equalization enhancement, and other deep learning models are also there. But this is, I think, it's kind of a low processing algorithm which can just smartly detect whether the image is overexposed or underexposed.
Okay, okay. Yeah. Over to the sir.
Okay, you have used the basis. You have converted the images to RGB, right?
Yeah, I've converted into RGB because as default it converts the image into blue, green, red in OpenCV
No.
whenever we load the image into OpenCV.
Okay, fine. So you have used this basis RGB. Do
Yes.
you know there is another basis for representing the image?
Sorry?
Is there any other basis for representing the image?
You can also represent it into an maybe there is, but I don't know of right now.
Okay, okay. So fine. You have worked on the basis RGB. So if there is any representation, yes, we can say there is a representation called hue saturation and intensity. So whatever the algorithms you have used in this RGB, will it work in the other bases also?
For now it won't, because we want it to be into an RGB format, because that's where we calculate the intensity of it, like red, green, blue. So it
Okay,
won't work.
okay, okay. Thank you. Nice presentation.
Thank you, sir.
Thank you, judges. Now I will like to hand over to my co-host Utkarsha to continue with the further event.
Thank you, Punyai. Now, I would like to request group number 3 to present on their topic applications of regression in machine learning. Kindly, please share the screen and start with the presentation.
Hello everyone. I hope there are no technical issues and I'm audible to everyone.
Yes, you're audible.
Okay. So first of all, a very good afternoon to Narendra sir and Sachin sir. And we'll just get started with our presentation. Our topic is application of mathematics in machine learning and more precisely regression. Okay, so my teammate is Vismay Malvia and myself, Shaima Feroz Khan. We are from Universal College of Engineering. So before getting started with our main core topic, let's lay a base, a foundation. Machine learning is a field of computer science in which we try to derive conclusions and make the computer capable to learn without it explicitly being programmed. There are three main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is like जब हमारे टीचर हमें पढ़ाते हैं, so वैसे ही कुछ कि it's like we give a labeled data to the computer and then we say this is the output and this is the input and this is the kind of output we are expecting from you. That is supervised learning. And in this we have classification and regression. So we'll be focusing more on regression. And then in unsupervised learning, the data is not labeled. That is, the machine has to figure out the hidden patterns in it. And in reinforcement learning, it is like unsupervised learning is like when you do not have a teacher and as an adult you're trying to learn things on yourself. And in reinforcement learning, if I put you on an island stranded, so that is like we just give our machine to external stimulus and then it has to interact with the environment and then discover actions. That is reinforcement learning. This is the flow chart of classification. And then we'll have our regression. Regression is basically the task of predicting continuous variables. So regression के बहुत ज़्यादा applications हैं and it is the most basic concept of machine learning, regression. Let's get started with regression. Regression has many types. There are linear regression, logistic regression, polynomial regression, and these are the basic 6 most famous, type or most used type of regressions. And the most widely and commonly used, which form the basis of machine learning, are linear regression and logistic regression. That is the concept that we are very first taught when we enter the field of machine learning. So we'll be looking at linear regression and logistic regression in my PPT or in our presentation. So in linear regression, what we do, we predict independent variable based on the values of we predict dependent variable based on the value of independent variable. Abhi dependent variable क्या हो सकता है? It is like I want to predict the stock price, वो हो सकता है, or else when I am trying to predict the price of a house or a property based on its area, there also we use linear regression. So what is the basic idea behind linear regression? If you look at this graph, there's a line. This is known as the best fit line. And what we do in linear regression is we try to find out this best fit line. This is the main objective. Finding out the best fit line so that we can, predict things based on if we have one variable and then we give it as input and we receive the other variable as output. So that is the basic concept of linear regression. So हमारी regression line की slope अगर positive है, तो it is like positive line of regression and then we have a negative line of regression. ऐसे दो classifications होते हैं. Okay, there are two major concepts involved in all the regression algorithms. One is the cost function and one is the gradient descent. So ये linear regression में कैसे work करते हैं? Let's look at that. कॉस्ट फंक्शन क्या होता है? बेसिकली जैसे हमने पीछे ये ग्राफ देखा, ठीक है, ये वाला, तो यहाँ पर ये जो हमारी रिग्रेशन लाइन है ना, इसमें जो डेटा पॉइंट्स है, डेटा पॉइंट्स और रिग्रेशन लाइन के बीच का जो क्या बोल सकते डिस्टेंस है, उसका स्क्वायर लेंगे ना. जब हम स्क्वायर क्यों ले रहे हैं? बिकॉज अगर हमारा जो डेटा पॉइंट है वो नीचे है और रिग्रेशन लाइन ऊपर है, जो हमारा प्रिडिक्टेड वैल्यू है, तो हमें नेगेटिव वैल्यू मिल जाएगी. सो एज टू मेंटेन इट पॉजिटिव वी आर स्क्वायरिंग इट. Okay, so cost function is basically summation of all the errors. Basically, जितना like predicted value से हमारा दूर है, like हमारे predicted value से हमारा actual value दूर है, that is cost function. So यहाँ पर this is the formula of cost function, and in gradient descent, as we saw, it is a line, right? So line देयर लाइन के ना हमें बेस्ट फिट लाइन चाहिए होती है. सो बहुत सारी लाइंस पॉसिबल है, ठीक है. सो उसके लिए m और c की बहुत सारी वैल्यूज होंगी. सो व्हाट वी डू इज वी कीप इटरेटिंग द वैल्यूज ऑफ m and c or theta 1 or theta 2. So to update theta 1 and theta 2 values in order to reduce the cost function. अगर हमें cost function को reduce करना है, उसके लिए हम gradient descent use करते हैं. So this is the equation of like the line, and this is the hypothesis equation of linear regression. Okay. Now the mathematics, जैसे हम जब इसको किसी भी जुपिटर नोटबुक या फिर किसी भी और सॉफ्टवेयर पे इम्प्लीमेंट करते हैं ना, तो हमें लाइक पाइथन की प्री डिफाइंड लाइब्रेरीज मिलती हैं. वी हैव predefined libraries of Python, but what is happening behind those libraries, that is what we are trying to explain in this slide. So let's say I have a very I have a basic data model और उसका मुझे ऐसे 3D ये मिला है, like graph मिला है. I have to predict कि how I have to predict regression, like basically okay, so note we are trying to minimize the cost function. So हमारा main is कि we will iterate m and c constants. Okay, we'll keep changing m and c till we find a combination where the cost function is minimized. So we define our जैसे इंटीग्रेशन में हम कुछ इंटरवल्स डिफाइन कर देते थे और फिर हम धीरे धीरे लाइक उनको ट्रैवर्स करते थे, राइट? वैसे ही हम कुछ इंटरवल से अपने ग्राफ को like divide कर देते हैं बहुत सारे पार्ट्स में, and then we move closer by that function and the slope slowly. और जैसे जैसे हम अपने रिग्रेशन के लाइक एल्गोरिथम को ट्रैवर्स करते हैं ना, तो हम जैसे जैसे m और c की वैल्यू चेंज करते हैं, तो ना एक टाइम ऐसा आता है ना जब उसकी स्लोप की वैल्यू 0 हो जाती है. पहले वो धीरे 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 कम होती है, फिर वो 0 हो जाती है. वो है हमारा मिनिमा. हम बेसिकली मैथमेटिकल पॉइंट ऑफ व्यू में हम उस ग्राफ का जो हमें उस वैल्यूज या प्रोसेस डेटा से मिला है उसका मिनिमा फाइंड आउट करने की कोशिश कर रहे हैं. सो मिनिमा हम कैसे लाइक मैथमेटिकली कैसे मिनिमा फाइंड आउट करते थे? हम लाइक एप्लीकेशंस ऑफ डेरिवेटिव 12th में पढ़ा था, राइट? सो वी डू वन थिंग, लाइक वी डू दैट अगेन ओवर हियर. जो हमारा फंक्शन है इन टर्म्स ऑफ m and c, इट इज अ टू वेरिएबल इक्वेशन. सो हम क्या करते हैं, हम पहले m के टर्म्स में उसको स्लोप निकालते हैं, दैट इज डिराइव करते हैं. फिर c के टर्म्स में उसको डिराइव करते हैं, एंड देन कैलकुलेटिंग, so we calculate the slope based on the current parameters. And once we have got that, if the slope is not 0, we'll reiterate. And then before reiterating, जो हमें अभी m और c की न्यू वैल्यूज मिली हैं, वो हम फर्स्ट लाइक अपने इक्वेशन में सब्स्टिट्यूट कर देंगे. और ये जो इटरेशन होता है, दिस इटरेशन इज कैरिड आउट thousands of times, hundreds of times based upon our data set or data model. We update the cost function with new values of m and c and repeat the iteration number of times depending upon our data set. Now, application of linear regression. Trend lines, GDP, oil prices, everywhere we use regression. So a trend line represents variation in quantitative data with a passage of time. And these trends usually follow a linear relationship. Hence, linear regression in future. We use regression in that as well. In economics and in biology. These are the application of linear regression. Now we have logistic regression. Logistic regression is basically supervised classification algorithm. What are we trying to do over here? जैसे रिग्रेशन में हम प्रिडिक्ट कर रहे थे फ्यूचर वैल्यूज, और हमारे एक ये लीनियर रिग्रेशन था, ठीक है? इसमें हमारे पास एक इंडिपेंडेंट और एक डिपेंडेंट वेरिएबल था. ऐसे मल्टीलीनियर रिग्रेशंस भी होते हैं. सो लॉजिस्टिक रिग्रेशन में व्हाट वी डू इज वी ट्राई टू प्रिडिक्ट कि हमारा पर्टिकुलर वैल्यू कौन से कैटेगरी को बिलोंग करता भी है या नहीं करता है. तो बेसिकली हम चीजों को क्लासिफाई करने के लिए लॉजिस्टिक रिग्रेशन यूज करते हैं. अगर आप सोचोगे तो लाइक इसका कहाँ पर हो सकता है एप्लीकेशन, मोस्टली देखते हैं, लास्ट में भी देखेंगे, बट ऐसे तो मुझे जैसे हम किसी को कुछ रेकमेंड करते हैं होटल्स वगैरह, उसमें लॉजिस्टिक रिग्रेशन यूज होता है. दैट इज हाउ आई एम फीलिंग, लाइक दैट इज. Logistic regression is a method to predict dependent variable given a set of independent variables such that the dependent variables is categorical. So when we were in 12th, once again, we studied a function known as the sigmoid function. Okay, so sigmoid function, what we basically do is, this is the cost, this formula over here, it is the cost of our logistic regression. But the basic approach of logistic regression is that we have a sigmoid function, and depending upon the various criterias, we obtain our data value points. And अगर like 0.5 से हमारे क्राइटेरियन से वो, and we define a criterion for that, ठीक है, उससे बड़ा है, so we'll put it at 1, and we'll put it in the category ki yes, it belongs to this particular category. If no, then we'll put it to 0, that is, it does not belong to this particular category. Okay, so ये precision और recall trade-off की तरफ हमको ये concept लाता है. So what is precision? Precision और recall का formula ये है. Precision is basically the ratio of true positives upon number of predicted positives, and recall is true positives upon number of actual positives. Actual positives and predictive positives का difference है. ठीक है. So low precision में it is like high precision or low recall. Let's just say कि very famous example of cancer patients. So we apply this when we want to reduce the number of false positives without necessarily reducing the number of false negative. Let's say when we are very confident that we want कि ना हम पेशेंट को बता दें कि तुमको कैंसर है और तुम इलाज करवा लो, ठीक है, and we, so that he can be saved. So what we do, we will reduce our criterion from 0.5 to 0.7 on this particular y-axis, so that जो हमारे पास डेटा है ना उसकी प्रिसाइसनेस बढ़ जाएगी कि हाँ इसको पक्का कैंसर है, मतलब 70% चांस हो गया ना फिर. तो ये क्या हो सकता है कि हाँ नाउ ही कैन बी सेव्ड. बट कैंसर, अब नाउ हमारा दूसरा अप्रोच ये हो सकता है कि जब कैंसर ट्रीटमेंट होता है तो उसमें ना लाइक बहुत सारा लाइक अनकंफर्टेबलनेस और लाइक इंसान लाइक बहुत सारी डिस्कम्फर्ट आती है, एंड उससे नहीं जाने के लिए इफ वी वांट कि लाइक मे बी उसको नहीं है लाइक कैंसर, सो व्हाट वील डू, विल डिक्रीज द क्राइटेरियन टू लाइक if he's below 0.5, right, so 0.5 50% chance hai. If we will decrease the criterion further like 0.3, and then we'll be like okay there is so and so chance, so that is low precision high recall. यहाँ पर precision low हो जाता है तुम्हारा but recall high रहता है. And now based on the categories, logistic regression is classified as binomial, multinomial and ordinal. In binomial what we have two possible types, जैसे कि yes or no. In multinomial we have three types, like disease A, disease B or disease C, or possibility A, possibility B or possibility C. And in ordinal we have very poor, very good. So each category can be given a score like 0, 1, 2, 3. Now these are the application of logistic regressions. Credit scoring के लिए we use logistic regression, and in medicine we use like medical information is gathered in such a way where a research group studies biological molecule and its properties, and then they publish a paper about it. So there we can use logistic regression. And in text editing and hotel booking, like hotel booking is like a lot of machine learning methods are used everywhere on hotel booking sites. Logistic regression is one of them. And this is a comparison of linear and logistic regression. We can go through it. So first is the definition itself. This predicts a continuous variable and this predicts it categorically. And then we have variable type. It is a continuous dependent variable and it is based on independent variables. Estimation method. इसमें हम least square method से estimate करते हैं और इसमें हम likelihood से estimate करते हैं. And equation is this: y is equal to b naught plus bx plus e, and this is the equation of logistic regression. And then best fit line, that is a straight line, and the linear relationship is not mandatory. Isme linear relationship between the dependent and independent is mandatory. And then we have it predicts integer value and it classifies the problem. and then the application business domain, forecasting, sales, etc. And this is mostly for cybersecurity, image processing, etc. So thank you, everyone. This is our presentation.
Now I request our judges to ask questions.
First one, you just explained linear regression and logistic regression. Which one is better actually, linear regression or logistic regression?
So that depends upon our problem. What are we trying to target? Are we trying to classify a data, or are we trying to predict its future value? That is how we will, you know, ऐसे regression के 35 types होते हैं. Like there are different types of regressions, and according to our need, we will choose what is the type of regression that we want to apply on our problem.
But how much regression is reliable? Whether it gives the perfect result? In case of prediction, you are saying that we are using it for prediction. Whether it gives the correct prediction or approximate prediction?
Sir, that is the main point of regression, that we are trying to reduce the cost function. Like error जो है ना, उसको minimize करने की कोशिश कर रहे हैं सर. तो depending upon it, basically depends upon our data set and our values. So there will be a little bit error, but up to, like, it would be up to the mark.
Okay.
There are very advanced algorithms as well that we can apply, but this is about linear and logistic regression, sir.
Okay, one more. You're talking about something high precision, right? How to choose
Yes,
that decision value?
Yes, sir.
Is there any mathematical method you are applying there to choose that decision value, or randomly you are choosing that value for high precision?
High precision value. So it depends upon when I got the function and when I have my result. So now it depends upon me what I want to derive from that particular model. So based on that, I will apply basically.
No, I'm asking how to choose that decision value you're talking about. You have to choose decision value that you mentioned to get a high precision.
Decision value will be between 0 and 1 only. Okay.
Yeah, but that is a trial and error or some specific method to choose that value? That I'm asking.
Let me just understand the question, sir. So I have my graph. Okay, sir. So there is two possibility. Either it is or it is not. So depending upon what I am trying to target, basically कि what data I want, मुझे क्या चाहिए, कि कितना precision चाहिए, high precision चाहिए और low recall चाहिए, या फिर low precision चाहिए और high recall चाहिए. Based on that, I will select my value, sir.
Okay. You mentioned while working on linear regression,
Yes, sir.
minimization of the function, right? Which is a function of two variables, correct?
Yes, sir.
Yeah. What is that? If you have two variables, then how to minimize the function? What is the procedure for that?
Sir, like we learned in engineering only, multivariable calculus we learned to differentiate differentiate a function with respect to two variables.
Differentiate. Okay.
Yes, sir. So that we can find the slope. Because slope, technically we use differentiation. Like it comes under the application of derivatives. So that is what we are trying.
But if you have two variables, then that should be partial differentiation, no?
Yes, sir. More specifically, partial differentiation, sir.
No, you never mentioned that is a partial differentiation. You are always saying that this is a differentiation.
Okay, sir. Sorry, it was my mistake. I did not mention, because I did mention it clearly that first we'll differentiate with respect to this variable and then this variable. Okay. So it was quite understood that it is partial differentiation.
Okay. Okay. Over to you, sir.
Okay, my first question is, you are applying regression.
Yes, sir.
Okay, so I am not able to understand whether you are applying regression to X and Y, but X and Y are variables. How do you claim variables? Whether they are attributes or variables?
Okay, yes, sir. So I should have, okay. So in this case, my M and C is variable. And why did I put it M and C? Because on a majority of the websites and wherever I studied or my references, they had theta1 and theta2. But as all of us are acquainted with M and C, so
wait. My question is not about M. M and C. My question is not about theta 1 and theta 2. My question is about X and Y.
Yes, sir. I am getting to it. So our variables are M and C. So this first point is established. Now regarding X and Y. So this is a iterative type of algorithm. ये रिपीट होते रहता है. So हम जब एक वैल्यू ऑफ X और Y के लिए रिपीट करें ना इसको, let me just go back to my presentation. Yes, sir. So we'll select one particular X and Y value, and for that we'll carry out the entire algorithm, and then we'll update the values of X and Y.
Saima, sorry to interrupt, but my question is not what you are doing. Okay. My question is about only X and Y, whether they are variables or whether they are attributes. This is my question. So what you are calculating and what you are not calculating, that is not my question. My question
X
is
and Y
whether X and Y are attributes or variables.
Sir, we are basically trying to find out X and Y only. Okay, so they are also variables, but when at different stages of algorithm,
okay. Yes, that's it. That's it. You claim that
sir,
they are
I would like
variable,
to.
right?
No, sir. I would
Yes.
like to add that they are attributes, and we are calculating the attributes on the basis of that. We are using the logistic regression, and the purpose of linear regression is to find the best fitted line. And for logistic regression, it is one step ahead and fitting the line values to the sigmoid curve. So basically, what we are calculating are the attributes, sir.
So you make it clear that whether they are attributes or variable, because Shaima is claiming that they are variables, you are claiming that they are attributes, right? So you are saying that they are attributes. Shaima is saying that they are variables. So
sir, I am
no,
not
sir.
saying
Actually,
variables. I am saying
no.
that on the part of the algorithm.
Shahima must have actually misunderstood the question because they were repeated many times. But what we are doing is, after using logistic regression and also the linear regression, when we see what is the purpose of it, we clearly see that we are using the attributes only and we are calculating it for attributes only. There are no variables, sir.
Very good. So first of all, you should say that X and Y are attributes, not variables. Okay, this is the first thing. The second thing is that now how much you are confident that your line, whatever your base fit, is correct. How much you will say that what is the confidence that your line that you claim to be base fit is correct?
Hello?
Yes.
Sorry, sir, I did not notice I was on mute. Can you more
Shall I
clarify?
repeat the question?
Yes, sir.
Yeah. Okay. So you have a data now. You have attributes X and Y. You have used algorithm and you have fitted a linear regression. So you have got a line now, correct?
Okay, sir.
Okay. So now my question is that what is the confidence or how much you are confident that this line, whatever you have obtained, is base fit? So I want to know the percentage of the confidence that this line is a base fit.
Sir, that we will understand by cost function. Basically, that will be that will define our error. So based on that, we can say how much it is precise.
Okay. You are a first year student or second year student?
Sir, second year students.
Second year student. So have you gone through the concept called correlation?
Yes, sir.
So have you gone to the concept regression, line of regression through the correlation, or directly you have just used the least square methods?
Sir, we have used least square method in this algorithm. Basically, correlate.
That is why you are not able to understand my question.
Okay.
So when we think of the variables X and Y, then we use this square method. Okay. When we think of the attributes, okay, then we don't go with this. Okay. When you approximate attributes with variable, then your first assumption is that I am assuming these attributes are variables, and then you are using least square method. Okay, but if you go to the correlation, so first we check the confidence that whether they are related or not, and then if they are related, we try to find out the line of regression. Okay,
Okay, sir.
so correlation coefficient is the measure of the confidence that you will have the correct answer between, or the relation between x and y, and that you have not calculated. Okay, but good try. Okay, good presentation. You have explored good concepts, and then your presentation was a good one. Thank you.
Thank you, sir.
Thank you so much, sir.
You're welcome.
Thank you, Dasre sir. Now I request group number 4 to present on their topic bias and analysis. I request group number 4 to please share the screen and start with their presentation. Is group number 4 present here? I think group number 4 is absent. So we should move with the next group. I request group number 5 to present on their topic matrices. I request them to share their screen and start with the presentation.
Okay, just give us 2 minutes, okay?
Yes.
Shall we start?
Yes, you can start.
Good morning, everyone. We are the students of AC Patel College, and we are presenting on the topic recommendation system using matrices and tensor. Next slide. These are my group members: Josna Parkedkar, Chirag Patil, that is myself, and Manish Soni. We are from the Artificial Intelligence and Data Science Department from AC Patel College. Next slide. So our main topic has three main subtopics, that is data representation using vectors, matrices, and tensors to represent data. Word embedding, it is embedding vectors to efficiently represent words for natural language problems, and dimensional reality, which will use eigenvectors and values to deal with the large dimensional data. Next slide. Now this is a vector. We all know vector is a quantity which has a magnitude and a direction. Next slide. Data representation. Imagine we have three columns: height, age, and weight. We can use vectors in order to take data from each column, that is 170 centimeters of height, 24 is the age and weight, and we can represent it in such a way which is understandable to the common public. Next slide. Similarly, the biggest property of the matrix is that it can take various data from any case possible and represent it in such a way and suggest what the next output the user will. Whether he will attend a session, he will not choose to attend a session, or he is going to do any action which is predicted by the matrix. Next slide. These are some systems in which recommendation systems are used. There are Netflix, YouTube, Spotify, even Google, etc. Next slide. From recommending movies or restaurants to coordinating fashion accessories, highlighting blog posts, news articles, etc., these systems are used. Recommended systems are utilized in a variety of areas such as Amazon, Netflix, YouTube. In the presentation, we'll learn the algorithm of matrix factorization and recommender system, introduction to matrix factorization, and matrix concept of matrix factorization. Next slide. We'll use of scalar, vector, matrix, and tensors for our project. Next slide. Matrix factorization. Matrix factorization is a way to generate latent features when multiplying two different kinds of entities. For example, imagine there are four users A, B, C, and D, and there are two types of movie, that is comedy and action. And the user A, B, C, and D rate the movies. Thus, the matrix takes data from both of these sides and recommends the movie and predicts that what type of movie will the user more likely to watch. Is he more likely to watch a comedy movie, an action movie, or etc.? It predicts using the matrix factorization method. Next slide. It also helps to recommend different types of movies based on kids, adult, teenager, and based on the age group, based on ratings of the movie, types of movies, and features. Next slide. Now I request Josna to explain further. Thank you.
Good afternoon, everyone. Now I will take over the presentation. So, how does this recommendation systems work? If you guys remember, when Netflix started in 2006, Netflix famously offered a prize to solve a simple problem, and that problem was uh, given that the given observations of a user. Uh, as well as the user's past behavior, predict whether the person will like similar kinds of things or not. So, like for example, if we take an example of a person A, his previous viewing history was Jurassic Park and Annie Hall. So we have to predict whether the same person will like the movie Matrix, or the person will like the movie Grapes of Wrath. So we can also represent this problem as follows. Uh, we can take connections between uh, people on the left hand side and the movies on the right hand side. If we are taking example of the movies, and we can connect them using lines, and the strength of these connections can be determined by the thickness of the lines. So now the problem is we need to find out the missing lines between the people as well as the movies. So the main problem is to figure out these missing connections as well as the values. So we can also mathematically represent the same problem in a matrix format, where the rows are the people and the columns are the different kinds of movies. So since we know certain data about a few people and movies, we have inserted those data into the matrix. So and the other data we don't know. That is the missing data we need to find out. As people have not seen these movies, also they have not rated these movies. So we have to figure out whether these people will like these movies or not. So if we take example of two features like comedy and action, we have to predict that whether these people will like it or not. So for example, if we take example of person A, so if person A likes comedy, we can represent it as a value of 3, as he likes the feature of movies of comedy, and the person A does not like action. So we can represent it as 0. Similarly, we can also represent movies with their features. So if this movie too does not have comedy in it, so we will represent it as 0 in mathematical terms, and this movie too has more of action. So we can represent it as 4. uh, so next, we need to find out whether that person A will like that movie or not. So in order to find out the person will like that movie or not, we will do factorization. So that is 3 into 0 plus 0 into 4, that is equal to 0, which means that our estimation is that person A will not like the movie because uh, uh, because uh, because the movie does not have comedy and the person likes comedy. So that is why the estimation is that person A will not like the movie. So next, similarly, we have to find this missing data of all persons as well as all movies. After finding those out, we mathematically represent those information in terms of two matrices, where the first matrix is all gives all information about the people, and the second matrix gives information of all the movies, uh, taking uh, taking two features as comedy and action, taking two features as comedy and action. So now to find out predict whether a person A will like the movie or not, we will do matrix factorization as 3 into 1 plus 0 into 3 is equals to 3. So we have predicted that person A might like the movie. So similarly, we will find out for all people and all the movies. So these are the values that we have got. So in order to put this on a scale of 0 to 5, we'll divide this by 8. So we get values in the scale of 0 to 5, and they are as follows. So this kind of approach where we uh, this kind of approach where we gather information about all people as well as all movies, and then predict whether the person will like the movie or not, is called as content filtering. There is one more approach which is called as collaborative filtering. So in collaborative filtering, let's say that we assume that we don't know these features like comedy and action, because there are many features in movies. It contains various features, so we can't stick to only two features. So that brings us to our next approach called as collaborative filtering. So collaborative filtering means, uh, let's say for example, person A might also like things that these people have viewed, and these people have similar viewing habits as similar to person A. So this is called as collaborative filtering. So in case of collaborative filtering, since we don't know the features, so we only know the values, and we can predict whether the person will like the movie or not. So since we know the values, we'll first find out the other two metrics, and after we have find out the other two values of the matrices, uh, we have then we can find out these missing values by simply by matrix factorization. So after matrix factorization, we have found out these values, and since we don't know the features, these features are called as latent features. So to summarize what we have done till here, there are two types of approaches where we can predict and recommend different things to people. One is content filtering, and the other one is collaborative filtering. In content filtering, we basically, content filtering means that whatever information we have about people and other things, we use that information to recommend other things to people. And in collaborative filtering means that uh, suppose if different people like a certain thing, so probably the other person might also like that thing. So next, I would like to ask Manish to take over the presentation. Manish, you can start.
Thank you, Jyotsna. So here, let's here be a Netflix universe. And in Netflix universe, we have four people as Anna, Betty, Carlos, and Diana. And also we have five movies recommended. And we provide ratings assigning from 1 to 5. Next slide. Let's say Anna provide 4 stars to movie 5. Next slide. Now we record these ratings in table where different users like Anna assign their different ratings on different movies. So these are the different ratings for different users. Now here we have three cases, and using matrix factorization or such machine learning tools, we predict which more cases are precise. So here in first case, every user provides same ratings to every movies, which say that is movies 1 to 5. Here we see every movies as 3 ratings is not possible or realistic, as every human rates to every movies is not possible. Humans are little more free. Next slide. In third case, Next slide. All ratings of different are marked as different random marks. So all ratings are completely different from all different users, which is also not possible because these tables has lot of dependencies as we humans sometimes are similar to each other. Sometimes the movies are also similar. Next slide. Hence, the table turns out to be the real one is table 2. Here are some similar patterns in users and ratings, where the user 1 and 3 have similar ratings, and in column wise, we see similarly in ratings at movie 1 and 4. Maybe that movie most liked by the users are Cops and Observe report. Next slide. Now the question is how we will figure out our recommendations from all these dependencies. Next slide. The answer is matrix factorization. Next slide. Simply we know that 6 into 4 give us 24. That is 24 is the product of two small numbers. Similarly, we will divide complex matrix into product of two like numbers of users into ratings based on features of movies. Example, whether it is comedy, action or romantic movies. Now, what's the conclusion of this factorization? That is matrix factorization will be explained by my teammate Chirag.
Thank you, everyone. Now it's the conclusion for all of it. The matrix factorization is a collaborative filtering method. Find relationship between items and user entities. Latent features, the association between user and movies matrices are determined to find similarity and make a prediction, like what type of movies will you likely see. The matrix factorization of user and item matrix can be generated when math cost function RMSE is minimized to matrix factorization. Gradient descent is a method to minimize the cost function. Hence, with all of these systems, we can easily predict what will be the likely movie that the user will see, whether he likes comedy, action, drama, romance, filter, etc. And this type of systems are used in every recommended systems, and more development is been taken place in this. Next slide. Summary points. We need to learn the mathematical foundation of data scientists are important too. Understand the fundamental principles of machine learning is because we need to understand how the system works. We cannot just rote learn different types of formulas and different types of systems without understanding the logic. In today's world, the whole world is getting connected more and more. Hence, these type of systems are likely to become more precise and more adequate in providing us with what we want. We will also learn about different inherent assumptions, limitation of the model, comprehend and debug existing algorithm approaches. Next slide. Thank you for lending us your patience here. Thank you.
Thank you, Chirag. Now I request our judges to ask any questions if they have.
Yeah, first one. In the presentation, it is mentioned content filtering and collaborative filtering. Which one is better?
So we can use both those approaches, but content filtering has one disadvantage that as we have various features, it does not include all of those features. We are limited to certain features.
So which one is
But
better? Collaborative is better.
so we can go for collaborative filtering.
Yes,
But
collaborative is yes. Please go
but
ahead.
we have also other metrics to determine the recommendations. Like for example, previous viewing history or the watch time of that video, or what are our patterns of viewing those videos. So those are other metrics we can also recommend using
Yes,
those metrics.
as in even today we are also seen like various applications like WhatsApp by Meta, Instagram by Meta, Facebook by Meta. So the world is getting more connected. So like that's why collaborative is more better as it takes in data from various applications and suggests like what is better for the user.
Okay. Okay. Next is now see when you factorize the matrix, you are getting one matrix there, right? After matrix factorization, you are getting one matrix. Is there any relation of that matrix with inverse of matrix? Have you checked with that? Any relation of that matrix with inverse? Because in one of the matrix, you are getting all the elements are same 3, 3, 3, 3, 3, right?
Yes, sir.
Yeah. So have you checked any relation of inverse because inverse does not exist for that matrix if all the elements are same.
Yes, sir.
So have you
So
checked that?
inverse does not exist. Actually, that matrix is not realistic. Where all the cells have 3 3 3 3.
Yeah.
That is not realistic because uh, we as humans we have different taste as well as different choices, likings and dislikings. So that is not realistic matrix.
Okay.
So differences occur. Like for example, if we watch a movie and we are watching it with someone else, and we like the movie, but if someone says the movie is the best in the world, even we say yeah, it was okay. Even though we liked it, differences exist. But that's what makes us a human.
Okay. Last question. What is that gradient descent? Hello. Am I
Sorry,
audible?
sir, can you?
What is that gradient descent? You explained last now what is gradient descent and cost function, right? So what is that gradient descent? Can you define that? Am I audible? Understood the question? I'm asking just can you define gradient descent? What is that gradient descent?
Sir, basically was a algorithm to find the minimum differentiation, like
About
how the differentiation between the ratings between different users.
Minimum and maximum.
but that should be some function, no?
Yes, sir.
What is that? I'm asking the same in terms of mathematics.
Hello.
Ah, yes.
Yes, sir. Gradient descent. It's like a maximum minimum function. Like what will be the output or what the user is giving us back, and it will then recommend. Like it's a there is a method, sir, in machine learning and deep learning,
Okay.
and it is used to make sure that like uh, it maximizes what the user requires and not just recommends anything. Like for example, if I watch a comedy, then it will recommend only comedy, like not that it will
Oh,
recommend others as well.
okay. 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 Overall, good presentation. Okay. Thank you. Over to you, sir.
Thank you, sir.
Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
Oh, okay, very good. So your presentation topic is good. Okay, so you have used one concept, latent feature, right? What is mean by latent feature? How do you calculate latent feature?
So latent features are like the features which are not so like they're kind of like hidden. For example, if I watch a movie, if I watch like anything, if I do anything like search a movie and etc.
Hmm.
So I like some part of the movie. It's not like just I just like the comedy. And even today's movie, they are not just complete comedy or complete action. There's a mix of both. So latent feature basically isolates an element that like this guy likes to watch action movie which has some kind of comedy, some drama. Like these are all hidden. It's not out there. Like not just like in bracket, like complete comedy or complete action. A mix of both. So that's what the latent features mean. Like they are hidden features, sir.
So we
In
can
terms
also
of
call this.
mathematics, in terms of mathematics, because you are calculating latent feature from some matrix. Okay, so you are calculating something from that matrix, no?
Yes, sir.
So what you are calculating exactly?
Sir, it is like a recommendation system. For example, like
No,
it
no, no, no,
recommends.
no, 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 no. I don't want to go to recommendation system. You are calculating latent feature from the given matrix. Correct?
Yes,
You
sir.
have formed, you have defined a matrix, you have formed the matrix, you know what are the rows and columns of the matrix. You are calculating something. This latent feature you are calculating from the that matrix only. Okay, so what exactly you are calculating?
So
How
we
you
are
are calculating?
calculating like the number of users or the number of ratings that
Uh,
is likely to give or what he
no,
likes to.
I think you are not getting my question. My question is simple. How do we calculate latent feature from the given matrix? What is the mathematical base? How do you, what formula you use to calculate a latent feature from the given matrix? What is the formula you have used?
Josna, I think sir is asking the multiplication of matrix like 3 into 0 and all.
No. How? My question is simple. How do you calculate latent feature from the given matrix that you have formed? Or what is the formula to calculate latent feature? We are discussing application of mathematics, so we should know what is mathematics that we are using.
So by simple matrix factorization, we'll find those.
There are several matrix factorizations. What matrix factorization you are using exactly? Go to your presentation. You can take a help of your presentation and explain me what matrix factorization you are using exactly. There are several. Okay, no problem. Fine. Go ahead. Thank you.
Thank you, sir.
Excuse me, Kamlesh sir.
Yes, sir.
Sir, can we take 5 minutes break? 5 minutes.
Okay. Sure, sir.
Yes, 5 minutes. Okay.
Okay.
Okay, the last we can discuss till that the sir will come back. See, those who have presented this project on matrices now, okay, Chirag and team. Okay. You are talking about a latent feature. So latent feature is nothing but your eigenvector that you are calculating with respect to some parameter. So the parameter that you have set, okay, are nothing but particular rows or the particular columns of your matrix, and then you are calculating actually the eigenvalues and eigenvectors of that, and these eigenvectors are nothing but the latent feature that you are calculating. So that's what I wanted to know, whether you can reach this concept of latent, you say latent feature, but it is actually eigenvector. So what you are calculating is the eigenvector, and then what factorization you are using. So there are several factorization. So the easiest is going to be the diagonalization using the eigenvalues and eigenvectors. Okay. So when we say that we are using a factorization, so we should be sure about what kind of factorization we are using. So the expected answer from you was this, that we are calculating the eigenvalues and eigenvectors, and then this diagonalization is going to help us.
Yes, sir.
Yes, sir.
Yes, sir.
So this is the base. Eigenvalue, eigenvector is the base for your project or your presentation that you have given. Okay. And then these values or these vectors related to eigenvalues, they form the eigenspaces. Actually, eigenvalue is also called as latent value. Eigenvector is also called as latent vector. So when we go to the terminology, different terminology, it gives you the idea. So latent feature is nothing but the eigenvector that you are calculating.
Yes, sir. The latent roots and all you're saying, right?
Yeah, it is the same.
Yes, sir. Now we remember. Thank you, sir.
Yeah, welcome. So I'll be happy if you have any questions.
Yes, sir. Like online, like we know the concepts, like it takes time to clear, sir. Now you have mentioned it, now we remember, like, yes, latent roots, latent vectors and all.
Yeah,
Thank you, sir, for your feedback.
welcome.
Hello, everyone. Shall we start?
Yes, we can. Yes.
Thank you, sir. Before moving ahead, there's a small announcement for all the participants present here. Please restrict with the time slot allotted to you, as we have to go with the other presentations also. It's a kind request to all the participants. Thank you. Now, moving ahead with the group number 6, I would like to invite group number 6 to present on the topic regression analysis and machine learning. I request to share the screen and start with their presentation. Yes, ma'am.
Is my screen visible?
Yes.
Siddhi, you can start the presentation. Yes. Good afternoon, everyone. I am Siddhi Salian from KC College of Engineering, Thane. Today, me and my team members, Homeshwari Thakre and Vaishali Chaudhary, are going to speak about regression analysis in machine learning. So, what is machine learning? It is an application of artificial intelligence that provides system the ability to learn and improve from experience rather than any instructions or tasks provided by the user. In simple words, it is a capability of a machine to imitate a human behavior. It allows the software applications to become more accurate at predicting outcomes without being programmed by the user to do so. For example, we might have observed after buying a product, we get this section named people who bought this product also bought this. So where do they get this data from? They predict those data with the help of machine learning. Now the question arises, how machine learning works? Machine learning algorithm is trained using the training data set to create a model. And when a new input is introduced to the machine learning algorithm, the prediction is done on the basis of the model, and the predictions are evaluated to check its accuracy. And if the accuracy is acceptable, then the machine learning algorithm is deployed. And if it's not acceptable, then it is trained again and again with the augmented training data set. Now, what is the role of mathematics in machine learning? Machine learning is all about mathematics. Machine learning means creating algorithm for computers to learn itself from data. Mathematics defines the concept behind the algorithm that can learn from the data to make the predictions more accurate, and it also analyzes which one is the better algorithm and why it is better. Predictions could be as simple as what kind of products to recommend to a customer based on their last purchase. There are four pillars of mathematical concepts in machine learning. They are regression, dimensionality reduction, destiny estimation, and classification. Further slides will be explained by Homeshwari Thakre. Thank you.
Thank you, Siddhi. Applications of machine learning. Some of the applications of machine learning are social media, whereas in social media, we can use facial recognition model. In transport, we can use self-driving cars, Tesla, financial services, stock price prediction, and in healthcare, we can predict the disease or some disease like cancer-related disease. And in e-commerce, we can use the Boston House prediction. In virtual assistant, we can use give example of Alexa and Siri. Next, the types of machine learning. Machine learning have three types: supervised learning, unsupervised learning, and reinforced learning. Supervised learning, it is a method in which we teach the machine using labeled data. Unsupervised learning, it is a method in which machine is trained on labeled data without any guidance. Reinforced learning, it is an agent interacting with the environment by producing an actions and discovers error or rewarded. The supervised learning is further classified into many types.
Some of the types are regression, decision tree, random forest, and classification. And the types of unsupervised learning are clustering, association analysis, hidden Markov rule. Next, in this presentation, we will explain the concept of regression. Regression. It is a statistical method which is used to predict the value of one variable from another variable. This method is also used to find the relation between the dependent variables and the number of dependent variables. This relation is in the form of a straight line that has the best approximated all the individual data points. In multiple regression, the separate variables are differentiated by using the subscript. Next, the types of regression. There are various types of regression, such as the linear regression, multiple regression, polynomial regression, multivariate regression, logistic regression, and the ridge regression. Further will be explained by Vaishali.
Thank you, Omeshwari, for taking this one. So, by using the concept of linear regression, we have implemented a regression model on the vaccination progress of COVID-19 during February 2021 to February 2022. For this, we have taken a data set of total vaccination, partially vaccinated cases, fully vaccinated cases, and death cases. Here, we will predict the near future case of disease with the given value of vaccination count. As you can see in the first graph, the vaccination count increases, the death cases are also, as the vaccination count increases, the death cases are decreasing after this peak. Because during this peak, it was around April 2021 when the second wave of corona hit. That's why, despite of the vaccination given, maximum number of people died during this period. And next to it is we have regression line analysis. These dots are the data values and calculated with the least mean square method, the best fit regression. There is a strong correlation between them. By this prediction, we have understood that if the vaccination count will increase, the death cases will automatically fade away. For this, we have to predict the future vaccination count, and we are using bivariate linear regression. Here, the total vaccination count is distributed as partially vaccinated and fully vaccinated. Means people who have at least have one dose and we have completed all the second dose. If you can see here, if you can see in the second graph, here from in the starting days, the numbers are rapidly increases, and there is an other line is slowly increasing gradually, because here the maximum number of people are already vaccinated and there are very few number of people left for the vaccination. So the line graph is increasing gradually. Next, we have multiple regression. We have interpreted the multiple regression to compare the distribution of vaccinated status among different age groups, from age group 18 to 44, age group 45 to 60, and above 60. Here you can see that Mumbai is in the top list, followed by Pune and the other regions. We have used 5 regions data set. And along with it, we have the 3D representation of graph. At x-axis, we have age 18 to 44 group, y-axis, we have age 45 to 60 group, and at the z-axis, where you can see the numbers 1 to 5, these are actually the serial number which we have represented the regions as the number. Next conclusion, we have concluded that by analyzing the regression, in future the vaccination count will increase and hence the disease case will decrease. For this, we have used the different types of regression analysis as we have seen. Next, the resources. These are the resources where we have collected our data sets. Now, how can we train a machine using all these mathematical concepts of regression? There are algorithms to train a machine. If you can allow, we can see here. We can show our implementation. So why are these algorithms used? The algorithms are used to convert all the complex mathematical functions into the simpler commands. Because the machine only understands the algorithms and we cannot use the mathematical function directly in the algorithms. These are converted into a computer program. For understanding the computer programming, we have to use programming languages such as Python. We have used here Python interpreting language. Till the machine didn't get the desired output, it will run over and over. It will iterate, and then when the machine will get the desired output, it will stop the iteration. You can see, for example, this is a basic database which I've taken from months February 2021 to February 2022. We have attributes at death cases, partially vaccinated cases, fully vaccinated, and the total vaccinated cases. For the first graph, we have plotted total vaccinated on the x-axis and death cases on the y-axis. These are all the graphs which I have explained in the PPT earlier. This is the second database for the multiple linear regression. We have taken the 5 regions along with the different age groups. Vaccination count. These are the linear regression. As we can see, using the basic mathematical, we calculate the R square, then the coefficient of relation, then model fit, then we predict the values. So algorithms in machine learning, this all reduces into one single command, which helps humans to calculate any or to train any model easily with less amount of time. Thank you so much.
Thank you, Vaishali.
That's our time.
Now I request our judges to ask the questions.
Whatever the data you have presented here, the graphs and all these things, or the algorithm, have you written this program yourself or you just copied?
Yes, sir. No, sir. We have written the program itself, and we have also collected the data itself by the site where the worldometer, where all the death cases of corona and the COVID app, where all the statistics are available.
Okay, means only data you have taken and algorithm you have written yourself, right?
Yes, sir.
So if you have written yourself, then you are which regression you have used here? Linear regression, logistic regression, different types you have mentioned.
Sir, no, sir. We have only used the linear regression, bivariate linear regression.
Yes. So what is the formula for that linear regression that you have used? You are saying that.
Yes, sir.
Yeah. What
so
is that?
So first we have defined a variable for the linear regression, then define the parameters which we are going to put on the x and y axis. And the formula is model dot fit. The model is we have defined the linear regression packages which are already available in the Python.
Okay, inbuilt functions are there. That
Yes,
you
sir.
are using.
Yes, sir. All the inbuilt function for linear as well as for logistic regression and for to plot the data are already available. We have to just import that data from the Python packages.
Okay. Very good presentation, and the topic is also good. That example you have taken, it's actually currently going on. So it's very good topic.
Thank you, sir.
Thank you. Over to you, sir.
Yes. Right now you have used the data set, okay, and you said that you have used it for training and predicting the values also.
Yes, sir.
Okay. So I want to know what is the ratio for training and testing.
What is the
model? What is the ratio for training and testing the model?
So you are saying the steps for the training and testing the model?
No. What is the, you have a data set, right? And you have a
Yes,
model.
Sir. Yes, sir.
Correct. So how do you validate your model? Okay. How do you say that this is the best model that you have?
Sorry, sir, I didn't get the question. I mean, how the machine will understand the what model it has to. Yes, sir. Yes, sir, you are audible.
Am I audible?
Yes, sir, you are audible.
Yeah. So my question is, when you make a model to fit a certain data, as you are using regression, so you are having a regression model to fit your data, right?
Yes, sir.
Okay. So how do you claim that the given model is the base model. This is the first thing. And what is the training and testing you have done with this model? So, what is the ratio of training and testing data set?
So the first, the machine will access the data set which we have, then within the data set we will give the algorithms and it will take the parameters or the attributes from the data set itself.
Okay.
Like sir, if I show you, for example sir, this is the data set we have created in the Excel file, in the CSV
Correct.
file. Correct sir. Then first we will make a parameter to access that file data set. Then we have given the attribute as death cases and attribute as total max, and also it is the inbuilt index values for the machine to understand which index value at what point it has to plot. Because the machine learning only takes the 2D array system, it doesn't take any variables or the string values. So we have to first model into a 2D array.
Okay.
Then defining that this is the x-axis, this attribute you have to plot in the x-axis, this attribute you have to plot in the y-axis, what kind of graph and what are you doing in linear regression. Then we have to install the packages of linear regression, and after that we can also
wait. Yeah, just wait. You have here visualized the data. You say you have plotted
Yes, sir.
this data. You have
Yes, sir.
visualized the data. And
Yes,
you
sir.
are talking about the linear regression.
Yes,
So,
one is
do you have any model for linear regression?
yes sir, we have enough. So the first, it is the just a representation of the data. Then that similar data we have first the model, these data sets we have defined that data sets, the attribute total vaccinated and death cases, and reshape that into the 2D array system. And then we have uh, for example, we have calculated the r square as we have calculated in the traditional method r square. Then we fit both the x-axis and y-axis, calculating the linear regression equations. So in this only one single model dot fit bracket x1 and y1. So it will it will create the regression fit line using these two attributes x1 and y1. And what are the x1 and y1? These are the attribute total vaccinated and death cases which we want to showcase. Then y prediction. So we want to predict the death cases on total vaccinated. So he will calculate the y prediction. It means new value of y, new value of death cases using the value of x1. So we have to pass the parameter of x1 into this model predict to make the predictions. Then after that we will have the ready new parameter, new prediction value of death cases in y predict. Then we have to just plot it in any graph, in scatter or in line graph, and we have to just label it, plot it x1 and y prediction, that new value that the machine has calculated. And this is the benefit of machine learning, that you don't have to calculate all the small parameters, all the small ratios, coefficient correlation, nothing. You have to just train the machine into such an algorithm that it will all this calculation, it is in the technical side. And the user will have only the access to the information.
Okay. So, still my question is unanswered.
Ratio that ratio.
Because you have a data.
Yes,
Okay. So, you are getting a model. So,
Yes,
are you validating this model? You are predicting that is okay. But do you think that your model is the best, or how do you claim that your model is best? So you are using a data set to construct a model. What is the percentage of data you are using to construct the model? Are you using 100%?
No,
Then
sir.
there will
No,
be
no, sir.
no testing
No, sir.
of
No.
testing of your
Yes, sir.
model.
Yes, sir. I understood. So we have used
Are you
as
testing
90.
your model?
So we have only analysis the data with only 95% confidence level, not the 100%. So there will be an error something, because in supervisor there are chances of highest true value, highest less error. So we have using the 95% confidence level where the range and all the true bin value will contain in it. And means there is a chance of only 5% error because it is a supervised learning. We have given all the inputs and the predicted desired outputs, so there is a less chance of error.
Okay. Okay. Thank you.
Thank you, sir.
Thank you, sir. Moving to our next group, I would like to invite group number 7 to present your topic on linear algebra. Kindly please share your screen and start with the presentation. Am I audible? Is group number 7 present here? I think we don't have group number 7 present here. So we'll move on with the next group, that is group number 8. I request group number 8 to share the screen and start with their topic application of matrices in uh, in data engineering, artificial intelligence, machine learning, etc. Hello, is group number 8 present? I think we don't have group number 8. Moving towards the group number 9, I would like to invite group number 9 to present their topic on convolutional neural network. Kindly please share your screen and start with the presentation. Hello, am I audible?
Yes, you are audible.
Yes, Utkarsha.
I request group number 8 to start with their presentation. Is group number 9 present here? I think we don't have group number 7, group number 8, and group number 9 present with us here right now. So we'll move ahead. The last group of the competition, that is group number 10. I would like to invite group number 10 to present on their topic linear regression, the helping hands in machine learning.
Yep. Good morning, everyone. I just wanted to ping Sahil. He just gone to drink water. Sahil, are you audible?
Yeah, you are audible.
Sahil? Hello, Sahil. Guys, just 2 minutes. He will just come back. Yep.
Hello, am I audible?
Yep, Sahil.
Good afternoon, respected judges and fellow students. Myself, Sahil Jadhav, and my group members are Pranjal Sonavne and Amay Vaukar. Our group topic is linear regression, the helping hand in ML. So what is machine learning? Machine learning is a subset of AI which enables the machine to automatically learn from data, improve performance from past experiences, and make predictions. Machine learning contains a set of algorithms that work on a huge amount of data is fed these algorithms to train them, and on the basis of training, they build the model and perform a specific task. From where to get the large amount of data? From us, the users. For example, captcha image. They ask us to select the image with the bicycles from the blocks on shown images. Our human brain knows how does the bicycle looks. So we select the image with the bicycle and help the machines by providing huge amount of data, and they can perform various sets of algorithm. There are four types of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. In supervised learning, house price prediction and medical imaging. In unsupervised learning, customer segmentation, market basket analysis. Semi-supervised learning, text classifications, and line finding on GPS detection. And reinforcement learning, optimized marketing, and drivers lens car. So, what is supervised learning? Supervised learning is when the model is getting trained or labeled data set. A labeled data set is one that both input and output parameters. Types of supervised learning. Classification. It is a supervised learning task where output is having defined labels. I mean discrete values like dog, cat, or addition of two numbers, that is 1 plus 1 is 2, having some fixed values. Likewise, we have seen the capture images that too comes under classification. Regression. It is a supervised task where output is having continuous values. Example, wind speed is not having any discrete value but is continuous in the particular range. Or one more example, that is increment in salary depending on the base of their experiences. Let's take a deeper look in regression. What is regression? We plot a graph between the variables which best fit the given data points. The machine learning model can deliver predictions regarding the data. In simple words, regression shows a line or curve that passes through all the data points or a target predictor graph in such a way that the vertical distance between the data points and the regression line is minimum. It is used particularly for prediction, forecasting, time series modeling, weather data analysis, software cost prediction, etc. Types of regression: linear regression, polynomial regression, logistic regression. So we are focusing on linear regression. It is quite simple statistical regression method used for predictive analysis and shows the relationship between the continuous variables. Linear regression shows the linear relationship between the independent variable and the dependent variable, consequently called linear regression. If there is a single input variable, such linear regression is called simple linear regression. And if there is more than one input variable, such linear regression is called multiple linear regression. The linear regression model gives a slope straight line describing the relationship between the variable, the best fit straight line. The particular graph represents the relationship between the dependent variable and the independent variable. Let's consider salary be the dependent variable and and experience be the independent variable. Where our experience increases, our salary also increment, and we can predict the closest approximate salary after a few years. Based on the given data points, we try to plot a line that models the point best referred to as best fit straight line. To calculate best fit line regression uses a traditional slope interception form following in the linear regression equation. Y represents dependent variable, represents independent variable, A0 represents intercept of the line, and A1 represents linear regression coefficient. Further will be explained by my Baukar.
Uh, there are two types of relationship in linear regression. First is positive linear relationship. If the dependent variable expands on the y-axis and the independent variable progress on the x-axis, then such relation is termed as positive linear relationship, as shown in the below figure. The second is negative linear relationship. If the dependent variable decreases on the y-axis and the independent variable increases on the x-axis, such relationship is called as negative linear relationship, as shown in the below figure. The main goal of the linear regression algorithm is to get the best value for A0 and A1 to get the best fit line. The best fit line should have at least error between predicted values and actual values should be minimized. Cost function. Cost function helps to figure out the best possible value for A0 and A1, which provides the best fit line for the data points. Cost function optimizes the regression coefficient or weights and measures how a linear regression model is performing. Cost function is used to find the accuracy of the mapping function that maps the input variable to the output variable. It is also known as hypothesis function. In linear regression, mean square error, MSE cost function is used, which is average of a square error that occurred between predicted value and actual value. By simple linear equation y is equal to mx plus b, we calculate MSE has uh, y is equal to actual value and y is equal to predicted values. Using in let's we have taken an example uh, for salary and experience. We will predict the impact of a year of experience on salaries. Uh, we we have taken um,
Hello.
okay. Uh, we have first imported a libraries. Um, uh,
I think Ame has facing some network issue. Let me continue from here onward. We have just imported some of the library using the pandas and Python. We can implement linear regression in any of the programming language like R or C++ or any of them. For now, we will use Python because it have already implemented model in TensorFlow. Also in the scikit-learn library, for this example, we have used the scikit-learn library, which have best possible implementation of linear regression, including all the exception handling. The team of scikit-learn library has made the amazing model which predict the value, including all the exception. Let's talk about some of the application of linear regression. Linear regression is prominently used in predicting the value, whether it will be the forecast or any software prediction or impact of blood alcohol or crime rate increasing or decreasing order, weather, temperature, or in crop yield, also predictive analysis, or to find any salary depends on the experience, where it have dependent and independent variable. It have the many more example and many more use cases where there are the two factor like dependent and independent variable, where we can use linear regression, and it have a very good amount of accuracy also. In summary, in conclusion, I would like to tell that in linear regression, we simply find the best fit line between the independent and dependent variable to make the model better predictive, and it will give the higher accuracy. We just have to find the best fit line, and our model predict the values with minimum error. Thank you.
Thank you. Now I request our judges to ask the questions.
Yeah. Pranjal, yeah, you have presented very well. I have a question. Uh, you just explained about supervised and unsupervised learning, right? On the basis of that training, you are building some models. So out of these methods, which method will give the best model?
Sir, for our example, we use the salary and experience. We have two variables, dependent and independent. Our salary was dependent on the experience. In that case, linear regression give the best possible outcome. The reason behind that is because there is only two variables, and I have practically done that project of salary prediction system. I have seen if our database has close enough, our database is pretty book and pretty accurate, it make the best fit line, also predict the value pretty good.
Okay. In cost function, you are mentioning A0 and A1. What is that A0 and A1?
It was the intercept line and the error. Like we have the best fit line. Also, our model predict one value around the best fit line. So the distance between our prediction and the best fit line is called error. If the error is minimum, we can say our prediction is pretty good to the point. If the error is too large, then our prediction is not that much good.
Okay, can you show your model? This is your model.
Uh, for the presentation, I have it was present in the GitHub repo, but I have not like run here on the system.
Have you
For
tried?
the presentation, I have just taken some code present in the slide.
But actually, you at least show your model, no, what you have made there. That is also important. No?
Yes.
Okay, that's over to you, sir.
I've done that project very early.
Okay, what is the programming language you have used for making this model?
Python. We have used pre-implemented library scikit-learn.
Okay. Okay, most of the focus is on linear regression only. Okay,
Yes.
why it is not compared with the other models, or why the other models are not fitted and then tested?
Uh, because we are exploring and learning the linear regression, and to make the presentation small and accurate, so we choose only one algorithm.
Okay.
There are also multiple, but they have the different use cases. Like multiple linear regression varies for the many independent values, and in simple linear regression, there are just two values.
Okay.
Sir, I'm not uh, finding the project, but I have done similar project. I have done. Oh, I got it.
Okay, no problem.
I'm
Thank you. Your presentation was good. Okay, thank you.
Thank you, sir.
Thank you, Pranjal. Thank you, sir. We were honored and lucky to have you all here on this special occasion. First of all, I would like to call out the group number 7, group number 8, and group number 9, as well as group number 4. Are they present here? Anyone? I repeat, group number 4, group number 7, group number 8, and group number 9. Anyone among these groups are present here? Okay, I think they are not still present. So moving ahead, kudos to all the participants for such great presentations. I would like our judges to give us a feedback about all the presentations presented today. Dasre sir, please go ahead.
Okay, am I audible?
Yes, sir. Yes, sir.
Yeah. Okay, so it was a very good experience to see all your minds presenting their concepts and the applications of these concepts in machine learning and data science or AI. Okay, so I'll like to suggest some few things. Okay, all of you have done very well. All of you have taken efforts. Okay, so that's very good actually. Okay, so only thing I want to suggest you how this is good, how it can be a better one. Okay, so please try to include the mathematics behind your concepts. Okay, so as we have gone through some algorithms, you are talking about MSC, you are talking about RMSC, you are talking about linear regression, but the confidence that linear regression will be or applicable or not applicable, or it will give you the results, required results or not. Okay, so that needed to be also explored. Okay, so when I say that I have a data and I fit a more linear model for that, okay, so what confidence I have, okay, so that also to be explained with the model. Then the training set, what is the training set that I am using for this particular model, and then whether I have tested this model or not. Okay, so what is the training testing ratio for the given model? That also should be included when you say from this data we are getting this model. And now when we think of the matrices in our theory, we have smaller matrices of order 3, 4, at the most 5. But when we go for real applications, real life applications, there are the matrices of order more than 100 by 100 and all. Okay, so I would like to suggest only the thing that please try to include some mathematical expressions, some mathematical concepts that you are exploring, or when you are doing any project, what is the mathematics behind it, or what is the concept behind that which you are using. Okay. So all presentations were very good. So thank you for giving us a treat of this all projects. Okay. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Now, I would like to invite Vani sir to express himself regarding this competition.
Yeah, thank you. It's a good experience to judge all these young minds here. While all they are presented, I found some points here that I will mention here. First, all the participants have really presented very well. Now, before you present, what you do, what I observed in one of the presentation, one or two presentations, they don't have such a good teamwork. So you always, whenever you are presenting, you first practice it in your group and then you present. So that there will be no last minute fumble should be there. You should be well prepared whenever you are presenting. Then next is all I explain the basic concept very well, but actually when they are presenting their models, that what actually that mathematics is there, they are not focusing on that. Yeah, nowadays we have programming languages and all these things, therefore they are not doing that one because all the work will be done in the programming. But you should actually explain that one also, that what mathematics actually you are using and how you are using. Then the professor also mentioned about that whenever you are preparing some model, you are constructing some model, then you check the validity of that model with other existing models so that you will come to know that which model is better. If your model is better, that is good. If your model is not good, then where you can improve, that you should learn. Then it is again good to see that all are interested in mathematics. So the mathematics faculty, I really enjoyed this. That engineers are also interested in all these mathematics to do all these things. Then one more thing, do some courses on data science or machine learning or artificial intelligence. That will really help you to build your career. When you are doing the engineering, you try to do some courses on that also. If it is not in your syllabus, some courses which are available on Coursera or Udemy, you can try to do these some courses also, which will definitely help you. And thank you, Kamlesh sir, for organizing such a wonderful competition. Overall experience is really good. Okay, thank you.
Thank you, sir. With
Thank you,
the great
sir.
reviews, with the great reviews by our judges, I am sure we all will learn many new concepts and new visions towards how maths is involved in data science, artificial intelligence, and machine learning. The results of this competition will be declared on our Instagram handle. So make sure you all follow the Inspire Maths Club. The link will be shared in the chat box as well as in the description of YouTube live stream. Moving ahead, I would like to request Avinash sir to give vote of thanks and say few words about the event.
Thank you, Utkarsha. Am I audible?
Yes, sir.
Good afternoon, all. On behalf of Inspire Mathematics Club, I, Dr. Avinash Kamble, feel privileged and take this opportunity to propose vote of thanks on this occasion, Math Pioneer. At the outset, first of all, I would like to express my sincere thanks to our judges, Dr. Narendra Kumar Dasre and Dr. Sachin Vani sir, for taking their time out and consenting to be a judges for this event. Thank you very much, sir. My heartfelt thanks to our beloved chairman, Dr. Vasudevan Pillai sir, for his thought-provoking address, support and guidance. You have always been an inspiration, sir. I would like to extend my profound thanks to our Deputy CEO, Dr. Lata Menon Madam, for her words of wisdom and for sharing her views. My generous thanks to our beloved principal, Dr. Bakul sir, for his enthusiastic support and motivation. A special thanks to our HOD, Dr. Manavendra Vasista sir, and the entire FE staff members for their constant support. I would also like to appreciate the efforts taken by all the students from different colleges in participating in this event. Finally, I would like to thank our team Inspire students and its volunteers for their constant hard work and dedication they have put together to make this event happen. Thank you, one and all.
Thank you, Avinash sir, for all the support and such a great vote of thanks. Now, I would like to thank our students, participants, guests, judges, and last but not least, our audience. Thank you for making this competition a great success. Thank you so much.
Thank you from our side as well for the Pillai College for the experience. It was really a great one.
Thank you so much. You all can leave the meeting now. The session has ended.
Thank you.
Thank you, sir. Thank you, Dasre sir. Thank you, Sachin sir. Thank you, Avinash sir.
Okay, thank you all.